This is discussed. We have finished that. Next one, setters and getters. One quick miscellaneous topic what we have here. Because the OOP part, object-oriented programming, most of our OOP is covered. Object, class, encapsulation. Abstraction talks, this abstract classes talks about abstraction. What we understand in abstraction is a method without body, that is abstract method. And that is abstraction because you don't expose the functionality, but you expose just method signatures. And that is abstraction. Provide what is essential and hide the background details. That's what we call abstract classes or abstractions. Providing essential features, hiding background details. And we do that with abstract methods by declaring them in abstract classes. Of course, we don't have any keyword like in Java, Scala, C# or C++. We don't have any abstract keyword here to declare abstract classes. Okay. So if we just declare abstract method in that class, it becomes abstract class. We consider it as an abstract class. That's all. Okay. So that's the idea about that part. And then coming to this setters and getters, this is a miscellaneous. Whatever we are discussing, we are going to discuss. Most of these are miscellaneous topics. So we covered complete functional programming of Python and object-oriented programming of Python. Both were covered here so far. Now a miscellaneous topic, setters and getters. Usually this is a standard practice when you are going for an object-oriented program. So in a class, you declare this setters and getters. Setter is used to set data, getter is used to get data. Of course, you know how to define objects or functions. The concept is just to understand like how we make that. But the point is setter and getter is not new for you. Means the point is you know how to define functions, declare functions. And if you know that, then setter and getter is not a big thing for us. Okay, setter means it's just any other normal function or a method exclusively used to set data of one and one. If we have 10 instance variables, we use 10 setters and we use 10 getters. For each instance variable, we use one setter and one getter. To initialize instance variable, we use one setter. To get that value, we use one getter. Like that, if you have 10 instance variables, then we declare 10 setters and 10 getters. Got it, right? So that every setter gives you an opportunity to initialize each instance variable separately. Got it, right? Suppose you take constructor. In a constructor, you initialize all instance variables in one go, in single go, in one shot. Okay. But in setter, it's not like that. For initializing each instance variable, we declare one setter. To return value of each instance variable, we use one getter. That's how we make this setters and getters. You got my point? Got it right, sir? So syntax is simple. Just to make sure it is a setter, we put a prefix as set here, or setter. Okay, set underscore that property. That is a standard way of declaring setters here. And as usual, you know, right, the parameters, how to declare parameters on that, because we are reaching the end of Python, and these things are very, very basic things for you at this stage. And you know, a setter has parameters. You can see, because setter is used to set data. Getter don't have parameters. It returns just the value. Okay. So getter don't take parameters. Self is common for any instance method. That's different. That is okay. That's fine. Leaving that self. Other parameters. Okay. If you talk about other parameters, then these parameters are applied only with setters. Okay. Getter don't have a parameter. It will just simply return a value. That's what getter does here. Okay. Is it clear for all of you? Now you take an example here. You see here class employee. So To set employee, like employee number, employee name, salary. You can see here, I use one setter to set the value of employee number. You can see here the parameter is enumber, and we set it to instance variable enumber, and one getter to get that employee number. One setter to set this employee name, and one getter to get this employee, and one setter to set salary, and one getter to get salary. And by looking at these methods, by examining methods or observing methods, you can easily understand that each setter is initializing one instance variable. Each getter is returning one instance variable. Okay, got it right? So finally, you can see here how we can use them. Now, when I have 3 instance variables, depend on my requirement. Suppose I don't want to set salary, then I can exclude salary, then I can set only employee number and employee name with this setter. I don't need to set sal here. I can exclude it if I want. Okay, that's how setters gives you an opportunity to choose which instance variable you want to initialize. Suppose if you must initialize all instance variables, call all setters inside the class. Call all the setters of a class. Suppose you don't want that, you want to initialize only few instance variables, then just only set those values to the object. Similarly, while getting values from the object, you don't want to get all the values from the object. You just want to choose only some specific values, then choose that specific getter to get that value. In that way, setters and getters gives you a broad scope to set data and get data to an object and to get it from the object. Got it right? What these methods will do, they set values to object, they inject values to the object, or they extract value from the object. That's what these methods will do. Got it right? That's how we can increase the scope of setting and getting values by using the concept of what is that, folks? Setters and getters. Got it right? So anyhow, you can test this example. So you can test this example how to set and get data by using setters and getters. And the similar concept in Java, we call this as a POSO. What do you call it, sir? We call it as a POSO, plain old Java object, or we call it as a bean. In Java language, we call it as Java beans. Even in Scala, these are called beans. If you go to C#, they call C# bean. This is a kind of design pattern. Okay? So what do you do, sir? Please test this example. Let's quickly test it. Even I will also test myself once by opening the PyCharm. Okay, on this one, sorry. Okay, let us test this here. So this is our program. On this, let's copy and paste this. Just testing to show you how we can play with this. So if you look at this code, we have 3 instance variables, 3 setters to set data, and 3 getters to get that data. Okay, one for each instance variable, one setter and one getter is declared. That's how we have to declare setters and getters. Now, if you see, once after I create object, to set each value, we use one setter here for employee number, for employee name, for employee salary, like that. What is that we are doing? We are using one setter here to set each instance variable. Similarly, we use getters like that. To get each value from each instance variable, we use one getter. Which one you want to call or which one you don't want to call, it's your call. It's up to you. Okay, just run it. So you can see here there is a small error. Let me check it. Okay, you got 10 and you got bound method employee get cell. Okay, let me check it out. Okay, you missed parenthesis. That's the issue. Nothing to worry. Now we get the output properly. Hope you can see, right? So employee number, name and salary. Got it? So this is simple idea about using setters and getters in Python. Even the similar concept is there in other languages as well, including C++. So why don't you test this program? Please test it. Take 2 minutes and test this program. Okay, sir. Let's move to the next topic. Even the same setters, we can also use some built-in annotations kind of thing. You can see decorators. Can you see these are the decorators? Can you see it, sir? This is the decorator. Okay. To set data, to get data, we can apply @ property. Okay. So this is the decorator used to apply with the getter, and this is the decorator used to apply with setter. Got it right, sir? Suppose you can see here. You can see here examples here. You can see, sir. I am taking one setter, a dot setter here, @ a dot setter. Means what? We are trying to set a value here, and that variable is a. And what we are doing here, we are setting this. Sorry, parameter is a, and that parameter is set to x here. And we are clearly saying that this is a setter here. Even we can also apply decorators, and we create setters like this. Can you see here, sir? And getter. You can see now this time you can observe one similarity here. Your setter name and getter name both are same. But how do I know which is setter, which is getter? That is where this decorators is going to help us. When you say @ a dot setter, that means what? Means whatever the name of your this one is there. What is that? This setter name that you are trying to use here. Attribute, you can see here, sir. Attribute dot setter. Okay, whatever the attribute. Otherwise, you can also cross check after that. Just only I'm giving you a quick walkthrough to get some quick idea. Okay, if you see here, whatever name of this one is there, this setter method, that you are trying to take it as an attribute and you are making it as a setter. Okay, and you are doing that. Even here, the getter is also having same name, but the difference is when you put this decorator on top of that, it acts as a getter. Also, other differences between these two is, if it is a setter, you just simply initialize here. If it is a getter, you just apply a return here. That is clear difference. And your interpreter will clearly understand when you apply these decorators. If it is seeing setter on top of this method, this decorator is there, then your interpreter thinks this as a setter. Suppose if your interpreter is seeing this decorator on top of this method, it definitely interprets this as a getter, and it will see return here as well. It's there. Got it right, sir? And finally, there is nothing to do here. Simply you can see here. And also one more advantage when you make it as a getter, see here. When you use this decorators, you can see you can use these setters and getters as variables, not like methods. You can see a created object for this A class. And then usually while calling method, what do? You pass values through this parenthesis, right? Through method call. But here, when you use this built-in decorators and when you create setters and getters, you can use setters as variables. You can use them more as variables, less as methods. Outside the class, this can be used like a variable, not like a method. That is the advantage what we have if you are using this built-in decorators to create a setter and to create a getter. You get my point? So this is as simple as like this, sir. This is like, more or less it is like you are making a call like this. How something like ob dot a of 10. Usually we call a setter like this, and we pass value like this, right? We pass value like this. But as you are making the setters with decorators, the advantage is the setters and this getter can be used like a variable, more like a variable, less like a variable. That is the advantage we have when you go with the decorators. And these are built-in decorators. Don't worry about it. Like I did create in it. Got it right, sir? Okay. So that's idea about this one, sir. Even while calling getter, when you say that ob.a, it's as equivalent like this, like this. This is more or less equal to this. Means when you call a getter, you just simply make it a call, then the value is automatically returned. Now, as you are using some built-in decorator, even this getter can be used more or less like a variable rather than a. Can you see this? Okay, right. This is simple idea about the advantage and the differences. If we what we have if we are using built-in setters and getters. Okay, when you are using built-in decorators, otherwise setters and getters are created by us only, but the decorators are given by Python. We mix them. We try to make it much more readable here by using this phenomena. Got it right, sir? So this is also another it looks really wonderful. So you see, it is adding some value to the concept here. Instead of going like this with too much of all that stuff, we can just simplify that with this getters and getters created through WhatsApp, through built-in decorators. That's also, this is a simple example. Let's quickly test this. How do you know that when setter is called, when getter is called? Here at this point, when you initialize a value to the setter, means what? You are making a call to the setter. When you just directly make a call without initialization, then you are calling a getter. That is the difference. Got it right, sir? Clear to all of you? Let me run this, sir. You get 10 obvious. This is another idea about what is that, how to rewrite this previous program by using built-in decorators for setter and getter. Okay, please test this.
Bro, did I miss anything? After abstraction, the setter and getter only, right? And then join later.
Yeah, you might probably, if you might have missed, you missed this one, Madhu. The previous concept of this, how to create setter and getter without using this built-in decorator. This one.
Okay. I attended this. I was there. Yeah.
No issues then. You didn't miss anything.
Okay.
Yeah, please test this, folks. Take 2 minutes. Test it yourself. Please confirm, sir, once it is tested. Okay, sir, let's continue to the next topic. So we're done with this. Next one, just understanding about private variables in Python. By default, everything is public in Python. Okay, like in Java or other traditional languages, we don't have keywords here. Like we don't have a specific keywords for public, private, and protected. Got it right? So if you ask me, then do you have any private keywords here, or do you have any public keywords here, or do you have any protected keywords here? No, we don't have any such keywords. To tell the visibility, visibility means what? Something like public, something like private or protected, or default in some languages. Okay, then how Python use this? How Python is going to show this visibility to us? How it implements this visibility inside? For that, you have to see here. This is a simple and quick observation. We don't need to worry too much about that. If you use double underscore with any variable or with any method, such variables or such methods, we can consider this as private variables or private methods. Default is public shell. Yes, the members are public. The variables, the methods, the classes, everything is public. And we don't have interface concept in Python because we don't have that issue of multiple inheritance in Python. Somehow they have handled it in a different way. That's why interface approach is not there here. We have just only a class concept here. And coming to the access modifiers, how they implement is not with keywords. How do they do that here? How do Python implements that access modifiers? Means by using this underscore. Okay, you can see here double underscore to declare private. That's what. For public default, everything is public. If you don't use any underscore, it is public. Okay, and they say protected, but if you just use one underscore, they call it as protected. But as per the documentation, we don't have much information about protected. Just if you use single underscore, you might assume that as protected. But if you use double underscore, it is treated as private. So with any variable or with any method, if you apply double underscore, such members are treated as private. And that is the basis for encapsulation. If you want to protect data, that's possible by declaring data as private. And how do you declare such data as private? A method or variable by using this double underscore. Okay. Usually, we declare variables as private and methods as public. That's the standard approach of implementing a class in object-oriented. We don't declare everything as private, sir. That is no use for us. We don't declare everything as public. Even we have limitation there. The actual standards to follow in object-oriented programming is your data has to be private, your methods has to be. And you can make it protected when you have inheritance. Suppose you are doing inheritance, in such cases you can apply protected. But protected is not that efficient here. I didn't see that too much of uses of protected in Python. Okay, but I'm just only giving you an idea, quick idea. So what is this encapsulation? Now we have seen abstraction with abstract methods and abstract classes. Okay, the only principle that is left behind in our list of OOP principles is encapsulation. Because we know object now, we know class, we know abstraction, we know inheritance, we know polymorphism. The only thing which is not discussed in this whole Python session is encapsulation. If I should talk about encapsulation, then we should know about private. So what is encapsulation? Encapsulation is nothing but simple. Protecting data, where you group your data, variables and methods into a single unit. That is what we call encapsulation. And we protect data. That is possible by declaring as private. What it writes here. How is it possible? It is possible by declaring it as private. Okay. But if you declare everything as private, do you think it is useful? Suppose variables data you declare as private. That is a standard way, because we don't expose data outside. But methods you have to declare public, sir. Otherwise, you cannot use that class at all. Okay, you have crores and crores of money, and you put it in bureau. Okay, you put it in a locker, and you didn't give that key to even your family member also. Okay, who is there in your house also, you are not giving it. Then what is the use of that money? Private is that. Okay, you protect data, no doubt, but you have to expose that data not directly but indirectly through methods. That's why you should declare methods public. Got it right, sir? Now if you see here, a small example for you. Now if you see here, in this example, we are just applying this encapsulation here. The same POJO we are using. Sorry, I cannot say POJO here because this is Python. The same setter and getter concept we are applying here. Okay, now if you see here, we are using a private variable here. Private. double underscore. Correct, sir? And here in the getter, you can see this method is not, methods are public here, but variables are private. I can only get this value only through getter. You can see here, I am returning through getter. If you directly access this, let us test it. If we can access this directly or not, let us test it. That gives you a quick idea. Other than replacing each instance variable in this setters and getters with this private data, we didn't make any much changes to this. Every instance variable is set with what's a underscore, employee number, and then name, and then salary. Only the instance variables. Means what we protect data here by making them private, and this is encapsulation. If everything is private, suppose if methods and variables both are private, then that is tightly encapsulated class. But usually tightly encapsulated class is not useful that much for us. Okay, why? Because nothing can be called outside. So we have to make it as loosely encapsulated. What do you mean by loosely encapsulated? Data will be private, methods will be public. That is loosely encapsulated method. Sorry, encapsulated concept. Or a class, loosely encapsulated class. And we can do all that with a class only. Encapsulation is applied in a class. Got it, right? Now you come down here. You see, you create an object here, sir. And you set data like this, and you get data. You get data like this. Nowhere outside class, it seems like you have a private data. If you look at this setters, or if you look at this getters, you don't feel anything like that. Actually, inside the class, we are doing encapsulation. We are implementing encapsulation, we are protecting data, we are hiding data inside the class itself. We are not exposing outside. And private data can be accessible only within that class itself. It is not exposed outside even to the other class in the same file also, or even to the subclasses. If you talk to the text, even subclasses cannot access this private. That's also, this is idea about what, sir? This one. Why don't we test it quickly, sir? Let us take this. You got idea, right? How to declare private data in Python? How do you declare that private access modifier in Python with any variable or with any method? If you declare it with double underscore, 2 underscores, then it becomes a private variable. Let's test it, sir. And the scope of private variables is class itself. We can access them only within that class, and private members are not directly accessible outside that class, sir. It's not possible to access outside the class. So let's test it, sir. Other than that, this setter and getter concept is clear for all of you, right? Do you have any problem? So now you see this, sir. This is private data, this is private data, this is private data. Some warning. Okay, it is asking, because I use setters and getters, it is asking to use constructor for that. Usually, right? Where do we initialize instance variables? Inside a constructor. You can do that as well. If you want, you can also follow that. Got this right, sir? So now we know this, sir. All these variables in this class employee are private data. They are protected data. Protected in sense encapsulated data. What I mean is, I don't say that protected access. Okay. This is private or encapsulated, and we can access such members only within that class itself. It is not visible outside. To test it, let's just quickly test it. First, we'll test it once. Setter will set value to each instance variable, and getters will return values. First, let's run this, and we get same data. Right at this level, everything seems to be normal. You don't even imagine that there is a private data inside when you are doing it outside. Okay, but actually we have a private data inside. Now what I do is, once after we call setters, that we can call that variables directly outside the class as well. Okay, so how do, let me just try to call them. You can see here, nowhere I am seeing that instance variables here. In this IntelliSense, usually when you say object dot, or when I say reference dot, when I say that, by now I should see that variable in the list in the IntelliSense, but I can see only methods, but I am not observing the variables. Suppose you see, sir, you remove double underscore here for salary. Now you observe here, somewhere you should find that salary, sir. No issues. We'll do one. This is get sal. Okay. I'll do one thing. In set sal, make it as a public. Okay. Now you try here, sir. Can you see sal? Now sal is visible, because sal is declared in that setter, not in getter. Wherever we declare, if you make it public, then it is visible outside. You got this right, sir? Means double underscore is nothing but it is a way to declare private members in Python. Is that clear for everyone, sir? So this is proved. What is that? How to declare private data in Python. So you can try that if you whenever you want it. Usually all this is applicable when you go for some web application development, or when you go for any, when you are building some objects for any algorithms. Only in such cases we make data like this. We follow this kind of encapsulation, abstraction, all these things. Suppose if we are using pure functional programming, we don't have all this there. We don't have this public, private, protected, all that stuff. Only it comes with this object-oriented programming. Is that clear for everyone, sir? Clear, sir? Is everyone clear? So why don't you test this program, sir? So run it once. There is some error. Okay, no issues. The issue is with getter here, no issues. I'm applying again underscore. Okay, quickly run it. And don't get confused, sir. Whenever we use the double underscore at left and right sides, means what? There are some special variables or some special methods declared in Python. Okay, they are not private. That is not private data, sir. Don't think that is private. If you put one more underscore at right side, again it becomes what? Some kind of built-in kind of methods there. Even if you want, you can also create like that. We don't have an issue. But they are not private. Got it right, sir? So anyhow, you can test it once, this program, because now you know clearly what is that difference between public data and private data. So far, whatever we have used is public, sir. Got it right, sir? Whatever we have used is public. Right now, once you prefix it with double underscore, then the member variable or method, it becomes private. Can you test it, sir? Okay, folks. So this is idea about this one. As I had discussed, access modifiers or access specifiers. So that we understood we can use public, private, protected in Python as well. But only thing is we don't have any keywords for that. The point is we use by default it is public. Every member is public without any underscore as a prefix. Okay. Usually we declare private members with double underscore like this as a prefix for any variable or a method, and protected members are declared with a single underscore. Okay, and we know usually public means accessible anywhere. Private means they are accessible only within that class. Protected members, usually where do we use them is if you declare a member as protected, means what? Such members are inherited only to subclasses, not to any other classes. Such members are called protected members. Like how our parents protect properties and give it to only their children, not to anybody else. That's what protect is. Private means suppose something is purely private to a parent, then even that he doesn't even give that to a kid also. Got it, right? If it is public, everybody can access it, like a trust kind of. Hope this is clear for you. Okay. So this is an example. Already we have seen some example, and even this is a very quick example. Just to quickly try this, you can see here double underscore is a private, and then single underscore is protected. This is public. Okay, but these are class variables. These are declared in class scope, not in method scope. Maybe you can test it with method as well if you want. You can test it in a method. Okay, so might be we can just quickly test all these three in one program. We don't need to again take too many examples. You can just take it as class sum A. Something like, you just take one method, P of M1, then what shall we do? Self dot. Now we know about private. This is self dot sum x equal to. What kind of member is this? This is a public member. Okay. Now self dot underscore x. This is y equal to sum 20. If you use just one underscore as prefix, it becomes protected. And then self dot underscore z equal to that. Now if you look at this all these three different variables, this talks about three different scopes. Okay, public is visible directly outside the class because it is public, and protected is visible within the same class and to the subclasses. We have finished inheritance. And private is visible only within that class, not even to the other classes in the same file, not even to the subclass. Okay, now we take one quick example. Let's first test it. Create an object a equal to a. Now call this method a dot 1, because without calling that method, point is it's difficult for us to invoke, because these values are not created in the object. We know, right? Only when you call this method, these values are added to the object. Otherwise, we have just an empty object in Python. It is much more organized. We have much more organized memory management in Python compared to things. So now you can just quickly test it. Print out a dot. When I say a dot, you can see here I am able to see only two members here. One is M1, the other one is X. Maybe let me scroll down if I can find anything else. I don't find anything else. Okay, so this is all metadata, sir. This is coming from its superclass object. Again, there is one more important point. Okay, I'll talk after this. But now I can only see 1x, but not underscore x, even underscore y or double underscore z. The protected and private properties are not visible on this reference. Can you see this? Can you see this? You are not able to see that here. You cannot see y, you cannot see z. You can only see x. Means what? Protected member is visible only within that class and only to subclasses, not outside directly. And private is much more restricted. This proves a point here. Now just run it now quickly. A.m1 missing one required positional parameter. Okay, so I'm missing parenthesis. Now it should be fine. Now you got it. So let's test a protected variable. Anyhow, public can be visible within the same class, or otherwise we can get this value through this method. Okay, maybe I can just print like this underscore y, then print out underscore z. Maybe we can also get that values through some other method. You can use a getter and you can try to get through getter as well. If you want, you can try that way. Okay, so now is that clear for all of you, sir? I'm just printing protected and private variable within the same method itself, wherever I have declared and initialized this instance variables. Okay, we can invoke through methods that indirectly, but we cannot directly invoke these members outside, this protected and private members. Okay, all right, just test it. Underscore y is not defined. 1 minute. Okay, might be I try to call like this. When I print it here, this gets created only when after calling this method. So what should I do? Let me do one thing. We take another method. You know, right, in Python, this instance variables are declared and assigned to object only when you call this method. Okay, after calling this method, then only they get declared and initialized. But by that time, I think that's happened, right? You are calling after that only. 1 minute. Let me. Score. Oh.
Self.
Yeah. Sorry, I forgot that. Thank you. Sometimes what happens is, yes, definitely we should use self, right? Completely, I am out of that. Yes. No need of this, sir, because when you call method, first this gets created, then only, right, we are doing print statements. If you put print statements at the beginning itself, then that is an issue for us, right? So this has to work. So my prompt, what is that? I ignored this self here. Okay. Anyhow, probably we fix this issue. Thanks, Madhu. Thanks for the update. Now let's run this. Okay, you got the data, right? Why you got 20, 31st and 10 after that? Because you print only y and z here. So m1 gets called first and then you are printing x. That's why you got 10 here. Don't think it is changing the order here. Output will come as per the order you print it. Won't do anything of by itself. Okay. That's it, sir. This is the idea about what is that? This one. Let me quickly test about protected variable, because protected member is inherited, can be visible or accessed within the same class where we declare, and only the subclasses as well. Let us test that subclass scenario as well. So B of A. Okay, now I'm not doing anything, just declaring a simple method and printing this data. Get data, and simply say self dot now I should see this what y and z, right? Underscore y. Even that is not getting inherited to the subclass. Okay, underscore z, okay, that's fine, that's a private variable. Protected at least has to be inherited to subclass. So here you can just say print of self. You can see x here, no doubt. Similarly, we should see, yeah, now I think I remember. See, we don't need to think this as protected, sir. One more correction, small correction to this. When you use double, even this is also treated as private here. Small correction. This is also treated as private. If we use double underscore, then this is actually what is that? It's more private. If you use a single underscore, this is less private. That's what the meaning. Somewhere I have read this. Let us just quickly analyze. Otherwise, if it is protected, it has to be visible in the subclass, because in all the languages this happens. Means this is not even treated as protected. The concept of protected is not applicable. Probably it's not applying here. So what we do is, I read somewhere, when you use this, you can see here private member. That is one thing. Protected member, this is not going to do that, because we are seeing practically. Do one thing. Give me 1 minute. Somewhere I read it. Double underscore is fine. That we know. Anyhow, we have discussed it. I don't think we have this protected properly applied here. They say single underscore, but even subclass is not able to invoke it. Protected attribute. They were saying we can invoke protected my attribute even outside the class, but I am not seeing there. Give me 1 minute. I'll conclude this. So as I told you, right, protected doesn't have much impact here in Python. So behavior definitely has some. We'll do one thing. We'll check for that. Study tonight. Everybody is applying underscore, but I don't think that will. Behaving as expected. This is our thing. See, that's what I am trying to tell you, right? This is a valid point here. You can see Python has no privacy model. There are no access modifiers. We have discussed that. There are no truly protected or private attributes, but still, of course, we can manage it with the double underscore for private. Okay. So you can see here now double attribute is changed into single attribute here. You can see, which makes it semantic privacy implied by this underscore. Means what? So it's something like this. The point is to conclude this. When you use single underscore, it's we can assume this as a less private or semi-private, not fully private variable. Because double underscore, it is treated as a fully private variable. So that's how this works. And that's why I'm not able to see in subclass. Usually it has to be visible, but we are not seeing it. But I'll do one thing. We'll also explore a bit more on this, and tomorrow I will update more about protected variables, not private. Because private is clear, public is clear. Only thing is we need to get that clarity on this. But still, I told you, right? Even this single underscore, we can treat it as a semi-private or it's more or less private thing, because I have read somewhere, still I remember. Even it's a kind of private, but what do you call fully private variables. And you can see here leading underscore just for non-public methods, and and anyhow I will check on it and get back to you. Got it right, sir? This is private. Okay, no problem. We'll talk on it in the tomorrow session. Hope apart from that you got clarity, right? At least to some level. The scope anyhow, usually protected members should be visible in the subclass, but we are not seeing that. So we can, for now we can stop it here. We can stop this discussion here about private protected members. Okay, I will talk tomorrow, and if anything is there, we'll explore and update you. What are the pros and cons about protect? Public is clear, protected is clear. Sorry, private is clear for us. Okay. So that's about this. All this OOP things here, encapsulation. Okay, and then the other things like setters and getters and how we can apply them with the other one, what we call decorators. Then access modifiers, how they are applied in Python, and the limitations we have seen. This anyhow we can ignore this. And super keyword is there here also. So we'll talk about this today and close this topic here. Okay. So when do we apply this super function here? It's very simple, sir. Super function is used to invoke superclass variables in subclass. If you want to access super class variable in subclass exclusively, this is applicable in overriding, because you can override variables in Python, right? Sorry, we can override methods in Python. When you override methods, your superclass method and subclass method seems to be the same. If somebody asks me a question, sir, how can you invoke a superclass method in subclass? That is the question. Already subclass has a method with the same signature. Now you want the superclass method to be called. Suppose you see this example, sir. What is the super method means? This is used to invoke superclass variables or methods from a subclass. Instance variables and instance methods from a superclass in a subclass. That is the idea about this. Okay, fine. Let's just see this. A quick example. We'll finish this today and close this discussion. Rest session. Suppose you have a class here. You have a method like this. Okay? Something like print of okay. Salman Khan. I'm just taking just some for some. If you like Hrithik Roshan, I will add that in the subclass. Class B. The one. I just make my method as what is this as some act. So same acting I am overriding. Suppose you are not satisfied, you right with the superclass method. We override it in subclass. So I put here something like Hrithik. Fine, because just these are Bollywood heroes, just perfect ID. Now I want to call this superclass method in subclass. Right? Now suppose I create an object for subclass like this. Now when I say b.active, by default the method of subclass is called. Correct? We have discussed this. When you override method, this method resolution or this method mapping, method binding happens based on object. Now object is subclass, the subclass method is called here. If you run this, you get what? Hrithik. Got it right? Suppose you ask me a question, sir, when in this case we have both methods are same in superclass and subclass. Now I want to access the superclass method in subclass. What should I do, sir? Okay. Then you can apply super method. You can use it anywhere, at the beginning or at the end, anywhere. So you can say some super dot. Now which method is called here? Super dot acting. Now you are a big fan of both. Now you don't want Hrithik. You want both Hrithik and Salman together in your own. Then I should call this superclass method in subclass. Suppose If I directly call acting, usually we can call superclass properties directly in subclass. Now, assuming that I am calling this superclass method, okay, I'm just trying to say here, if you see here acting, I'm having an error, no doubt about that. Why error? When I call like this is a recursion, infinite recursion. You are calling the method of same class itself. This doesn't seem like you are trying to call superclass method. Now, if you put your cursor here, unresolved reference acting. Okay, of course, I'm sorry. Again, I forgot self. Okay. So now this will work, but still this is actually, there is a flaw in this. We have a flaw here, sir. What's that flaw? This is recursion. When you declare like this method call is not going to call method of parent, but it is going to call method of itself. If you try to run this code, it leads to overflow, stack overflow issue, recursion error. You can see there. This is a stack overflow problem. Maximum recursion depth exceed. Why? If you declare here, it is trying to call method of same class itself, this subclass method itself. It is calling it again and again and again and again. How many times you can see the output here? You might see here. This keeps coming. You see the output there. How many times Rutik is printed there? Can you see that? Did I run my program that many times so far? I didn't do it, right? You got the point? Means what it is calling? This is a recursion. When you put like this is going to call method of same class itself. So I want to call method of super. Then in front of this, what you have to do is simply you have to say super dot unit. I don't think you need self this time when you are doing this, because you are calling method of which one, sir? Parent. So I don't think self is necessary, but let me test it, sir. This time first we get Ritik, then we get Salman, because when you say super dot acting, then it is going to call method of superclass, not the method of subclass. Now let me run it and see what happens. Now here when I call acting, then this method is called, and when this method is called, first Ritik is printed, again super method acting is called, then Salman should be printed from this method. Let's run this now. Yeah, you can see they're both. You don't need to self here now. Got it right. If you are calling individually, then we need self. On super, I don't think you need that. Can you see that? We can see both Ritik and Salman. Can you see it, sir? So this is the idea about super method. And usually, when should we use this super, sir? When do we use it? We use it when both the methods of parent and subclass are same. Okay, suppose you might have a variable like this. One more use case. Self dot. Let me test one more scenario, and then we will close this session today. Okay? And here also, I will say self dot x equal to something. Now here I am printing this 30 here, and here I am printing this 10 here. Okay. Now let me run this. So I'm sorry. You're right. The weekdays usually we do Scala. In Scala, the print separator is plus concatenator. Here we use comma. That's the issue. So that's what it is giving me left and right. Now you got it right. Suppose I want to invoke now. If I print, I'm printing directly 10 now. Then let me print x self.x. And here also self.x. Okay, fine, sir. Now again you might ask me a question. When this variable here in both parent and subclasses are same, of course the values are different, sir. Can you see this? Now you ask me a question, sir, I want parent class variable to be called in subclass. I want to invoke variable of parent in subclass. What should I do? Then what we can do? Then again I can take the help of what? Super dot. Can you see this now? Means what? Super method can be used in two ways. It is used to call superclass variable or superclass method in subclass. Usually when do we go for using super? When the variable or method of superclass and subclass are having same names, then you prefer super method. Otherwise you don't need super. Why? Because you can use directly those variables in the subclass. Only this is necessary when you have similar variable and similar method of superclass in subclass as well. In such case, we use super to invoke superclass members in subclass. Now you run this program. Super object has no attribute. 1 minute. Okay. Super object has no attributes. We should invoke this. By default, it will invoke some class 1. I'll do one thing. First, I will call this method here. After that, I'll call the variables. Okay. You know why? When I call super method, then this should declare and initialize. This should get declared and initialized. So once that is created, probably we might call this. Let me test it once. Still, I am seeing it. Salman Khan 10 is there. And it's calling Salman 10. Let me call it like this. Can't we apply this on variables? That is the next question. I'll do one thing, sir, just for testing purpose. Making this as acting one. Anyhow, you know the concept. We are calling acting one. Even when you create separate object, also it will be specific to only to that object. It won't be directly called to subclass. So in this case, I'll do one thing like this. There is a way for this. That doesn't make any sense here. That is not how super has to be applied. You can create an object for A and you can call it. That means you create an object again, it is a totally different concept. Okay, it's not like that. Without creating object, you can be able to call this. Like if you see, we are able to call acting method, right? So similarly, did I create any object here? I didn't create any object. Directly invoked it. Similarly, I should be able to call this variable as well. So probably otherwise, super method is not applicable for variables. If it is not giving output, means it might not be applicable with variables. Let me run it then. It's printing 10, right? Okay, I'll do one more last thing. Self.x. Even this is not turning this to seems like the super method is not applicable with variables in Python. Sir. This is completely modifying this x to 10 itself. Okay. So overriding this, and as a self dot x equal to 10, if you see there, it's overwriting. Print of self dot x. This time we are going to get, probably I'm expecting 10 this time. Yes. Means what? Even here when you call acting, it is overriding this x, which is declared in a subclass. Now when I say super dot x, it's not working. Super dot x is not done. One more last scenario. Let me comment it. Now let me call this x now without commenting this acting method. Let's see what happens. It's not working. Okay. Probably the conclusion might be this invoking variable with super method is not applicable in Python. Even I will just explore on this and update. But this is simple idea about super keyword. Leave about the variable part. It's not supporting. Variable is not supporting. So usually this super method is applicable when we have overriding methods. In other cases, it is not necessary. It's not necessary. So that's the idea about super keyword. I mean super method. Please test it once, then we'll close the session. Can you please test it? So there is two more topics what we need to discuss. Here is one is regular expressions, and then exception handling and multi-threading. Probably tomorrow we will complete regular expressions. We'll finish regular tomorrow. One more week for us, and finally the next week will be the final week for us for Python. Hope you have tested this, folks. Got clarity, right, about all this setters and getters and the decorators to implement setters and getters, and then the super method. And also we have discussed about one more scenario. What is it? Yeah, the access modifiers in Python, that public, private, protected, and we have discussed all that. Right? All of you are good now, sir? Hope this is clear. Probably tomorrow we'll close the regular expressions. There are few miscellaneous I need to discuss tomorrow about whether protected is how protected works in Python. The second one is variable overriding. Do you have that in Python or not? We need to conclude this two and finish this. Probably we might finish regular expressions tomorrow. Then I will take to the introduction level. I don't go too deeper into the regular expressions. Understanding that basic part is very important, and we will apply those basics of regular expressions on a couple of use cases, and we get some clarity on that. Then we will move to the exception handling and then threading. That we probably next week should be the last week for Python, because we have almost covered everything. If anything is there, we will do it as a workshop, like 1 day workshop, 2 day workshop, like that, 2 hours workshop, like that. Okay, so that's how we plan after that. Okay, even we continue with analytical Python after that. Okay, so slowly we'll make it as workshop kind of thing. So that's what works. Any questions, Madhu or Vinod or sir, all of you? Do you have any questions? Others, Deepak? So, okay, folks, thank you so much. We'll meet again tomorrow, same time. Probably we might close that regular expressions.